Okay, so here's the situation. We have two identical blocks of given mass, 0.12 kilograms. They are on a frictionless surface. They are initially at rest, and they are connected by an unstretched spring. We are given values, like I said, initially at rest. We have x1, which is 0.02 meters, x2, which is 0.04 meters, and x3, which is 0.1 meters. And we are asked to find how far the system moves, how much work is done, what is the final translational kinetic energy, what is the total mass of the system, and finally, what is the final velocity of the center of mass. And here's a diagram of our situation. And it wants us to find all of these using the point particle system. Alright, let's get started. First question, how far does the system move? Well, because we're using the point particle system, our system is only a point. So, if we have that knowledge, then we have our x1, which is 0.02 meters, and it moves 0.04 meters, which means our final position is going to be 0.06 meters. But this is asking how far the system actually moves. So we need to do our change in position equation, which is x final minus x initial. And then through your calculation, you'll get our change in position, which is how far the system moves, to be 0.04 meters. Next question, how much work is done on the system? Well, we know that we know that work equals force times change in distance. Well, let's change variables. I like to change my variables to lessen the confusion so I don't get confused on what's what and where it goes. So let's see, we have work equals force times delta x. And because we are given our initial conditions and we are given that we have a constant force on this system of 10 newtons, we can easily calculate the work done. Our constant force of 10 newtons times our previously calculated delta x equals 0.4 joules of work. Next question, what is the final translational kinetic energy of the system? Let's start from a fundamental principle, the work energy principle. Work equals change in energy. And then we can move on and expand that a little bit. Work equals the change in translational kinetic energy plus the change in gravitational potential energy plus the change in internal energy. Now notice that I have two of these values equal to 0. These two values are equal to 0 because we're in the point particle system, and the point particle system only deals with one type of energy, and that is the translational kinetic energy. So from that we can expand the change in translational kinetic energy to K final minus K initial, but K initial is 0 because our system is initially at rest. So therefore our final translational kinetic energy is equal to work, which is 0.4 joules. Next, what is the total mass of the system? Well, that's simply using our given masses, m block 1 plus m block 2 equals 0.12 plus 0.12, which equals 0.24 kilograms. And our last question, what is the final velocity of the center of mass? Well, we have to start from a fundamental principle again, which is the work energy principle. Work equals the change in energy. Expand that. Work equals the change in translational kinetic energy. And from what I told you before, you only deal with the translational kinetic energy. So then we get, as previously told, work equals K final minus K initial, but K initial is 0. Then we can expand our kinetic energy to 1/2 mass total times v squared center of mass final, and we can go through the algebraic steps to find the velocity of the center of mass final, which then equals 1.83 meters per second.